Okay, again. Let's have a quick recap of what we are doing. JSON to PNG data conversion system. There is some good news. Let's look at the final result, then back up and then come up with an explanation. This is this is the set of numbers I will see. Firefox. Let's do previous session. So I have some data here. Wind is a series of numbers and letters. In here, I'm interested in extracting 220 and 0026. This one being the direction, this one is speed. And I'm also parsing out the other properties here. So far I have worked out a system where we are converting numbers of different scale or magnitude. For example, this one is, I think this could be maximum 160,000. In this case, this is like 10%. So we also have another conversion system here where we actually see that 10% too. But this is also converted to graphic file. Good too. This one. It's too tiny to see. I'm also writing only the first row, and today we'll continue writing the remaining pixels. But this is essentially what you see in numbers. Those colors are these values. When it's 1, it's 100% white. It's like this. I'm actually taking this as a red channel, and then the next two as green channel, the next two is blue channel, and it's alpha. This one has no alpha, but it has 10% red. We could actually detect that here. So there's a successful conversion. Let's pick this, and you can see RGB10 00. There is a problem with the way Firefox is displaying the alpha value sometimes, which is here. In this case, it's correct, but if you use the color picker here, sometimes this always reverts to 100. So, or it always kind of reads the previous value. I don't think this is 0, because if you go and then come back again, you'll actually see that it's real value. So, but I know that the conversion is done because the next goal was to read back from this image the original values. That is done here. These values are these values, which is also this. So that's good news. Now we have to look at edge cases. Should be on our way. Let's go to VS Code. So we have a few edge cases here. There's the edge case where the value of something changes sign. So you go from plus values to minus values, or from minus to plus values. It's easy to pick a color when the range is not changing sign. You could assume this is black and white, and any color, any value in between is just kind of grayscale value. Here you need two fields store the information. One is the numerical data, and one is the sign, whether it's positive or negative. That's one edge case. The other edge case, which I haven't fully tested yet, is sometimes the value of a field, data itself will be either at the minimum or at the maximum. So instead of being somewhere in between, the value will be either this or this. So of course, when it's this, it's going to be 0, and when it's this, it's going to be 160,000. Now, with the way I'm storing the color data, this is the kind of assumption I made. Present a case here. For example, we are converting this guy. You can actually see this 610027 in here. Again, it doesn't take into account the alpha properly. Second time it will. The 61,027 and 34%. This one is the 34%. These are 255 scale. This one is 100%. But this 34 corresponds to, because 86 over 255 is like 1/3. So this is actually mapped correctly. Now the calculation for it is done so that when a string like this is in the loop here, we are considering these two. Let's say red channel, green channel, blue channel, and out. That's what we are doing. So then this number turns into this color. So when we read it back, there's the decoding phase where we read the channels. We multiply the channel values by 255. But here's assumption. I put 0 dot because when I was doing this conversion, I was including everything after 0 dot, 0 point. That's what this regex is about. What will happen if the real value is pure 0 or pure 1? Now, I am actually doing those cases. It's a bit of a special case. Fine. So this is actually marking the colors here, pure white. That's the data I have. And I could easily have pure black too. So at this level, the work is done. We are not breaking it down by channels. We are kind of hard coding those channels. It's like this. It's all 0. And this is all 0 here, but the magnitude is 1. So it's actually pure white. However, during the decode phase, we are only interested in these. So we don't actually know when we read these values here, if they all come 0, whether they actually had 0 point or 1 point before coding is done. So we are not really carrying this information into coding. So that's a new problem. But I just want to see the compression rate. Just going to remove this break state. And as far as I know, this data is already prepared. It's image data done. You just have to trigger this in. But when I did this, I have to okay, it should say whether file has been encoded and put a whole bunch of letters. That's it. So this file is now going to be updated. Let's close it. Oh, instead of commenting this one out, I commented the first loop, which put only 1 pixel. It's done. Reopen it. And we have a file full of colors and alpha values. This file, it is 9 by 8762, is this. It's array JSON values, and all this is, and this JSON structure doesn't look meaningful, but if you open this in Excel, that graphic file is essentially representing all this data. For the time being, only this part, minus some redundant parts here. The 6 qualifiers here. So the next task, one of the next tasks, will be including these optional parts, because sometimes they don't exist for some hours. But here's what we can do. The parts that I want to include are essentially here in sanitized JSON file, and it's the file size. So that information is now encoded to 124 kilobytes file. So that's a massive gain, or drop rather. Massive benefit. And this doesn't increase linearly. Nice. If we have 10 more dimensions here, like instead of 9, if we have 90, this doesn't go up to, this is not multiplied by 10. When the image turns into a more square form, there is some internal optimization done for us automatically. So we'll see that too. So as I was stating, there's no way for us to know whether all zeros mean pure 0 or pure 1, because we have now lost the you know, this part. It's time to make a decision. Time to make a decision. Let's output these two as well. This is that signature change. Maybe before that, let's simple case. Sea level pressure is SLP, I know that. The qualifier is pressure. And in the case of wind, you gotta specify either direction or speed. You could have multiple measurements for a certain weather quality. For wind, you have two. The pixel here is going to be, since it's 0 indexed, I have 9 values. This is done at the encoding level, so we just do this. We don't do this part. We just do this part. So let's look at our data. Let's say 10, 1, 3, 4. Now the goal is to read these two values, search and do here. I know I'm not exactly answering the minimums and maximums, but this is part of the problem about the, because to force the sign, I made a deliberate decision that normally all the other values, simple values, are kept in 1 pixel. This is wind direction, wind speed. Look at here, let's see. Wind direction, wind speed. This is ceiling, cloud height. This is visibility, 10%. Okay. Then for temperature, because it's 16 in the positive, this white declares that it's a positive value, and this is 16. The intensity of these colors are contingent on that qualifiers range. So although you may see similar colors in the wind range, this is sort of like percentage wise in a similar value in this guy's minimum and max. Color it makes sense in its own scale, but this is indicating that this is going to be 16 in the place. If this was dark, this would be minus 16. Now this sign problem is a similar problem to the minimum, because if this was a single field value like this one, imagine wind speed or wind direction according to specification we have. If this was white, without meaning that it's a sign pixel, we still wouldn't be able to read the original value. So I'm gonna try to figure it out for the sign case, because I think I'm going to have structure this differently. Start with the air temperature. Similar. EMP is the temperature. This is already where we are struggle with the 4 is the sign, 5 it's the value. 5 is the value, so you cannot just decode this you almost need a custom decoder for some qualities. It's as if I need a it's as if I don't need to know this, that I should just be able to say decode this quality for this measurement. We are measuring wind for these two qualities. And then we shouldn't actually know this at this level. That should be kind of looked up for us. Similarly, we say, I'm interested in knowing the temperature. This case, because it's kind of 1-to-1, but internally it's going to know that it has to operate on pixel 5, 4, and 5. At some value, something like this has to be done, but as a hidden process that I'm not making a blanket assumption here. That's like, well, this is how you read all the values. It can't be that simple. And also when we convert the values back, I'm already taking into account their proper minimum and maximum here. So we do denormalization here. So let's see, I might mess this up real good, but let's write a denormalize function. I don't know the parameters yet. It almost start to look more like this. Need to pass value. Just return it without converting it to string. Just value. And here you just do denormalize the rise value. We are passing the ID and measure. One more. Okay, this should work as before. Again, I'm not encoding it. I'm encoded data. I should be able to read the values. This is apparently wrong. This is actually kind of correct, but wrong. When we did the normalization here, this is where we were separating it into two. Let's look at the temperature data structure. So there is the normalized decimal value, but also we are keeping the sign. Right now, we are actually passing this sign. We are not passing the value. So let's assume it's positive. So it's a naive calculation here without knowing the sign, because we know the original data is positive. This will at least give us the positive value. Problem though In the denormalization, this minimum is going to be the real minimum. This. In fact, it should be 0. So because when the values are positive, your range is from 0 to 18. You can no longer include the full range for the normalization. So there has to be something similar to this at this level. But I was reading the sign pixel anyway. This is the real value pixel, at least. This is going to be way different anyway. Still wrong. 16. Surprisingly, that actually is the good answer. Still don't know the sign. I'm actually curious how this worked, because I was expecting some bizarre answer. Yeah, look at this. So value is coming in as for 16. What are we sending in? We are sending this. It's actually coming in here as this. Red, green, blue. And you multiply it with some value. Colorize value. Which is actually here. I'm already printing it out anyway. This is just a float version of this string. So this is like 61%. That's the value coming in here. Delete this garbage. So value here is this. Now you multiply it by this. Sorry, max minus minus. So this is the whole range then. Which is 618 plus 932. So you multiply this by 61, 16, 12, 90. Plus you add the minimum. Which is not... Then round it to 16. Okay, that actually checks out. But we still don't have access. When we read the sign, we should actually have this. Instead, we are going to get all zeros. That's how I structured it. Scrap. So here the fifth one will say 0. Sorry, I said zeros, but okay. Interesting. It's as if the channel value is 1. Why are these one? Fourth pixel. This is actually the fifth one, which is actually 100. Wow, 255. Okay, 255, 255. It's all 255. Okay, I'm kind of answering my own question. All the other values are always below 99. Because since I'm always taking two digits, this can either be 00 or 99, anything in between. So if I register 255 into the image, that's going to come here as 1. 1 times this is 255. So this is that pure white case. So I can actually do an if case here. The opposite case, initially when I did this business here, when it's all 0, yeah, because I'm doing this here, I have the safety net, because when it's all 0, that's what I was afraid of, not being able to stand this. But since in this case I'm doing all the ones and in this case all the zeros, so when I'm reading all the zeros, all the 0 times 25, this is still going to be 0. There is going to be nothing giving me, there is no other case like 2.0, 3.0, because I already normalized it between 0 and 1. For these to be all zeros, it means the beginning value should also be 0. For this to be all 255s means that this used to be 1.0s, so that forced 255k. Okay, so this is good. I still think this really should be in its own method. Hello, sir. Or this is the first time I'm seeing your Snow Amazon. I think we've met recently, no? The nickname rings a bell. Would you happen to be Yanni? Last Sunday we were going to talk, and then I talked to Dimitri. I think you might be that person. But hello to you, and you have a nice day as well. I'm guessing it's already evening over. We have to check for this case and the pure zeros. Just trying to come up with a smart way of writing those two if cases similar. These two. Yes, you are Yanni. So welcome to the stream. I'm guessing your power outage problem has resolved. I hope everything is working out. Can I do something dumb here? When we have an array like this, there's no shorthand method to take the sum of. You can do some dumb thing like this. If you add the value for all those channels, it's 4.0, this is the maximum case. Okay, if it's all 0, then this is the pure 0 case. I think I should first look into these two cases even before I do this. So let's do this first, the 0 case. Again, at this point, do we make any judgment about identifier itself? Because we're already splitting into denormalization. So this is analogous to this one. So if that's the case, I could pretend that my plot value is something like this. Say you are float. Colorized value is this. Here we can assume that this is hard-coded from this. Similarly, when it's adding up to 4, it used to be this. Anything else is going to be calculated and then be normalized. This might actually work or not. There are only two possibilities and one way to find out. Well, something may be working, but I'm writing test case here to see if it's working or not. Also, this is when I do this, I'm still proceeding with this, which is not good, so I should be bailing out here. Let's do an elif case, else case, push everything here. So then you can smarten up here. Okay. At least I don't have those 255 parts. I feel like I'm seeing something wrong. Yeah. Thank you for stopping by. It still has a very long way, but slowly but surely we'll get there. If I could figure out this encoding part, converting weather data from files like this into this, which is the weather data, believe it or not. This is 1 year's weather data for Toronto, all these colors. So I'm going to decode this into real values. This. It's about data compression at this point. This 618, I think this is wrong here because I'm probably outputting the wrong value. But this is good news. This 618 is proof that file 618 is the maximum for the temperature. So it must have got 1 point all the way 0, and the denormalized version of 1.0 is the maximum. You already know that. So I think this is solid, except the decision making should not be done here. There should be a higher level function that should now decide whether this is going to show minus or plus, and then also in other words, We cannot really do it here at this level, so we need that higher level function, which is interesting because I think we are going to lose this in all the decodes. We only need to pass the ID and the qualifier, or those two terms are interchangeable, but this will have to go into its own separate function because decode sounds more like, well, I'm interested in decoding this measurement for this ID. And then you decide internally whether you're interested in pixel number 4 and 5 or sometimes just one value, whatever those values are, how they are going to be handled, which is this process. This should be done in a separate place. This is when I feel like I'm running out of names. This actually sounds more like, yeah, I'm really decoding the color in numerical values. Think of either a really smart name or a dumb one. Figure it out. Okay, that's the function name. It's really dumb. Figure it out. What are you trying to figure out? You're trying to figure out this. And so this should only be interested in the color, nothing else. The color should be given to this decode function based on some kind of lookup, something like this. When it gets really scary a bit. If match ID is wind, then we have the result here waiting for us, which is a string, let's say. Result will be code. Then we shamelessly take this part. So then this is, let's do R, say figure out next, replace. Okay. But there are two measurements here. I cannot just go by ID. This is gonna sound dumb, but we are always writing some kind of prototype anyway. If measurement is direction, then result is this. Else, there is only one other measurement we make under wind, which is the other one, so 1. And of course you need this. Here, but see, without passing the IDs and measurements, the normalization won't know the I still have to keep this here. So decode is going to do what? You still need the ID and measurement. So you just pass them along, but you don't make that decision here. Now, this is where things also get redundant. The reason why I'm putting 0 here is because this is the 0th row. This is like the column number. It's counterintuitive. It looks opposite. When we go higher in the first argument, we are going across here. We are going 1, 0, 1, 2, 3, 4. Then when you go and do 1, 1, which is speed, you are reading 1, 1. Which means too many screens. When you try to figure it out, you're not only figuring it out for the first hour. You need a hour marker here, so that would be here. Hour will be an integer. But otherwise, you are passing the ID and measurement. What am I missing here? The identifier image isn't declared. Image get pixels. Because where is the data, right? Maybe I will write singletons, or I'll know which data I'm working on. For now, I'm passing the data as well. Image is good. Data is an image. That image happens to be this image. So when we figure things out, we gotta pass these and that's it. Of course, this will be changed. Like, let's keep writing it. If it's sig, we don't have any if else case. We just do else. It's the 2, and because we are giving the measurement here, we don't actually need to. So this is going to be more or less standardized. We could even do some kind of mapping later, which is something that I'm planning to do. Which means a different file like this. Here, this is a dictionary. So the code doesn't know if the wind is defined as the first key for this min-max dictionary. But we know certain values about it. It's like for the direction, we could have minimum maximum values. So somewhere here, or in a different dictionary structure, we could map something like this. Wind's direction quality is always mapped to this pixel. Then wind's speed value is mapped to this. So we don't have to hardcode these values. If that is the case, then this whole thing could just be this. I would say, well, go figure out this number based on ID and measurement. For that hour, figure out its value, decode it, give it to me, In other words, figure it out. What if I relabel this? What if this was no longer min-max? This was weather elements. Weather elements wind direction has particular minimum and maximum. Here's the column, the pixel order. Pixel. Five pixel for now. Good enough. This is 0. This is 1. This may seem like a dumb experiment, but we are going to skip one number here. That's why there's some value in this. It's 2, 3. 4 is the sign. The value is actually 5. This is the sign. 5 is the. So then I'm only going to write the edge cases here. Something like because I know that these two are straightforward cases. They could be sort of default case. Well, if it's default case, figure this value out by looking up the ID and measurement in here. ID and measurement. Find its pixel value, 0 or 1. Just slap them here, okay? So now you don't really need to do this. And not even this. Because there's a chance that I'll end up writing a very long match list, which is not. But I'm already seeing a pattern here. So if now change, right? This is also wrong in here min maxes. Yeah. This file has to be relabeled. This is going to be ISD in the end. So if ISD min max for now, weather elements. Right. If this ID and measurement is really very similar to this. Has key pixel problem is whatever I'm trying to figure out, I already assume that this, if this exists, this must, because I'm not writing the signature. This is not going to be the if case. This is going to be the result case. So this is going to have a pixel. That pixel is going to be the x. The y is the hour. So the exception here is temperature. Yeah, this is where some magic will happen, some crazy stuff. Just pass. Also not correct. The default case was, I think this was the default case. If it's default, then figure out x gives results. I have something copied to the board. Result is empty still, but here result will be this. This is the x, and here, because the code should normally return only the value, so smart, we do string here. Because in the game we'll need to hold a real data, numerical value, str result. That's it. Yeah, this is always going to be this. Because it's finding the x internally anyway. This is that edge case. Fish. Here we go. All null. Okay. Apparently this didn't work. Let me go to documentation. Godot, learn statement. Change default to a single underscore. That's what I did. It's not 1 or 2. I don't care to. Could be doing something, yeah, with the array pattern too, passing TMP and something. Anyway, those are fancy cases. This should have worked. In fact, if it's this, print something. Clear. The fact that it did not. What if I do this? Are you really literally return the results? You are not printing this out either. This is always null. ID is a string. Which, do you really mean this? Underscore. Because instead of string underscore, I'm in the wrong place. Something. Okay, so this is good news. Don't need to print something anymore. Yeah, underscore meant as underscore. Text underscore. So now I have to wrap my head around this. So can confirm all the rest is perfectly calculated. In the case of TMP, temperature is one of those edges. Grab some water and come back. Let's see. So if it's temperature, we have to break this down into two different procedures. We cannot just make a blanket assignment like this. That I'm writing that here. It's 5. This also comes with its own signature. So this is 7. Again, these numbers may change regardless of the order. Measurements and IDs. Maybe this is even in a JSON file that both Node.js and Godot is sharing. Because I think when I did this SLP, I lost it because I didn't actually push before we were getting SLP as well. Now let's figure out these two bad boys. Here's what I'm going to do to simulate the hour, because I know in each case I'll do 10. I will replace this. What am I doing? 10. Okay. On this. Here's an interesting case. Now, 10 is this case. Of course, when you look here, it's all decimals, more human readable format. Let's use it this way. Hit break. Okay. Let's look at this data. 270, 0067, which is just 67, and then SIG is 1740. Visibility is 19,312, and the pressure is 10,126. Good. Now, here's the problem case with the temperature and dew. One is plus 10, the other one is minus 10. So, without making any calculation here, let's pretend that our result is this. In the case of temperature, this X was the pixel value, right? We kind of know that the value for that is 5. We could actually look that up too, I don't know, but we are first interested in finding the sign too. So this, except this is going to be 4, is going to be the sign. In fact, we could kind of figure that out here, right? For the dew, they are more or less the same thing. You still pass this. And let's just put the dew temperature for hour 10. Okay, minus 10. So I'm a bit confused about this. It's as if it's already doing its thing. Why am I keeping the pixel for the sign then? Did I have to do this? Okay. Too many things have been happening lately. Maybe during the normalization process, I really have to do this. But then that nominal value, when it's denormalized, it's taken into account in the context of full range. Full range is this range. This range. Here's an interesting case. When I bind the temperature, if it shows plus 10, our work is done. The reason why I'm saying that is because well, obviously the number is going to look okay, but how it's done, even more surprisingly, this range are not the same length. But if it figures out plus 10 and minus 10, well, it did for minus 10, for a different length of wider range of numbers between min and both cases, then we are done. So maybe don't even do this. Just let it go. So in this case, temperature will try to be calculated just like the other. Did this, right? Yeah. Accumulated. Okay. So we are done. Interesting. Which means we don't really need to write this anymore. We need to figure this out still from which pixel, so we don't need to pass the number manually. That has to be coming from some data structure, which is okay. But which means figured out could easily decode. Let me wrap my head around this new development. It's surprisingly beneficial. So instead of figure it out, pretend we are doing it. Don't do this anymore. Say, all done. So then I do code here. I need to be passing this into change the tune a bit. Get a bit more space. Decode image hour. Before I said figure it out, we figured decode here, right? Get pixel. Remove this. You know, this is sort of redundant, but what if we did it this way? Because I'm overloading the meaning of functions otherwise. Let's say this is it. That we are interested in str result. Yeah, this is where we have the discrepancy with the string result. Or this is all garbage. This should work. Fish. Good. Now we could get rid of this part. Hey, it's going rather well. A bit complicated. A lot of calculations, number punching, but it's going well. How about you? Just about to write the timer here with the hour changes so we can see these numbers go from one row to the next. So where would that be? So here's our field. Let's hide you. Let's stick label here. Maybe a timer here first. This timer's name will be our timer, let's see. Cool. Are you into Godot? Or are you here for just general game development? Maybe urban farming? Feel like don't remember your nickname, or it's been a while? Might be a new viewer. I don't. Feel free to introduce yourself. I try to answer as much as possible. Occasionally I miss the messages in the chat window. So every 2 seconds, this should do something. What should it do? On our timer timeout, this should something like this. Increase the value of our JavaScript. Let's do it this way. Cool. Yeah, my streams are very long usually. Either Here people like it because there's calm music in the background, or people hear my voice as the background noise while they are at work, or simply the streams are just too long. I don't always do visual stuff, so it could be a little bit dry. But either way, welcome. So this local hour is gonna go away, so that we benefit from the hour change. So as soon as we hit the simulate button, here's an interesting case. Am I locking and unlocking file here? I could, but this is where we could start the timer too. Do timer. Timer? Where's timer? Hello? That's bizarre. Okay, we just do start. Do I have any showcase of game on channel? Mostly when I catch you, I see you coding. Yeah, it's. You might have seen the teaser trailer. We do have some Blender renders. Not actual gameplay. We used to have one. It's kind of broken though. Ashamed to admit it, but I'm actually trying really hard to simulate this weather data. Maybe that will be the visual showcase. Otherwise, what you are really seeing on Steam page, we have Figma designs. Some UI stuff is done. Things are all over the place a bit. We have made a lot of progress in certain areas, but not integrated. This is the new inventory system. We have the shop window. Might have seen this already. Context menus. It's not going to be multiple screens like this, but we are working out different phases. Rain barrel information panel or composting unit. The raised bed information. We have things like this too. That's the showcase. Wow. It's as if the stream is disconnected. I might have just reconnected again. Okay, I guess I'm reconnected again. I don't know. It's as if the numbers looked all the way down to 0, and it said reconnecting. Okay, you might have heard me answer your question or not, but I'm repeating. Yeah, we have some screens done. Some of these have been implemented, some not. Yeah, it is a very complex game. We have basic planting mechanics done for demo purposes, but again, they don't really do much in the big picture yet because the weather system is not implemented, and that's what I'm trying to do here. So I have weather data. This is hour by hour for 2010, and there's wind direction, wind speed. I'm trying to simulate this in Godot for now, and that data has been converted to an image like this so that it's compressed, and I'm trying to read back from here to get back to data like this. So, and eventually what we will be simulating here will be visually in the game. Maybe sometime Wednesday or Friday I could actually start showing these values. So I want to visualize it this way first in this UI. which is pretty much here, mind you. Like either you see it here or you see it here in game world. But more importantly, what I would like to do is I'm gonna put a plant here in the background, and if the temperature is dropping, the plant will either die or survive, that kind of thing. So I want to see the weather effect on the plant, so that will be starting sometime later next week. Knock on wood. But it takes a great deal of data, manipulation, data wrangling, cleanup. When the timer starts, I'm doing this the wrong way, I think. The order of things here. I think I'm going to write another function here. Start relation timer. Such a dumb name, but all this is going to do is this. When the timer kicks, so when we click simulate encoded data, we land here. Which is doing particular hours simulation. Instead, it should start the timer. Yeah. Thank you for checking out. I'll be having a lunch break and then I'll continue after. So maybe if you're around, you'll see that I'm doing the hour by hour simulation. Or check the stream sometime next week. Maybe I'll do a devlog. I'll summarize all this. But thank you for checking out. So we need to pass image here, and we do read that image as a result of this, which is so we do have image to simulate, which could just be again, this is all faking it. Here, image and data are interchangeable. Data to simulate is this. Right. But now that it's this, here's where we'll do timer starts. Maybe this timer. Dude, seriously, timer. So when the simulation file or the data file has been selected, we load the data, we start the timer. When this timer kicks in, it's going to do this. We don't need this anymore. And then it's going to simulate. And what is it going to simulate? It's going to simulate not that. Wow, you could actually do it this way. Data to simulate. Or this simply reads from data. So this should work. Fresh. Farmer tools, clear. I could put. Where are we here? Let's put some hour value here. I'm gonna put an H box. Put 2 labels. I'm going to say hour. I'm going to say this is actually kind of the title. This whole thing is the hour. This is going to be the value, and going to say hour. So when the hour starts, or the timeout, you are also going to do something like text is going to be our str, and otherwise it's always 0 anyway. Again, come here. So every 2 seconds an hour goes by. Okay, we are in simulation business now. Get the data. Hour 7. Try to keep up with the let's open 15, 16 by the time we get to it. Of course, am I gonna make sense here? I won't. Okay, go back to more textual data. Let's go to 21. Expecting to see 330 in the hour. 21, good. So let's look at 25. I'm expecting to see minus 60 minus something. I already passed. 31 minus 110 minus 30. Awesome. So this is very good news. I think this is also good news. Ceiling height, this is the maximum, but not the force maximum. It's the real value maximum. The only missing part here, which is maybe not a big deal for the sake of simulating it here, that this air temperature we see is actually Celsius, but it also has to be divided by here's what we can do further here. This shouldn't be hour, this should be date time. Yeah, hour. You need 2 more things. You need day. Let's call it hour value. With day value. This is about data storage. Most fundamental part here is these values. There is date value, hour value, hidden here. There was a prior conversation whether we should extract those values and put in the data file. The reason being, when you look here, this is the first day of the year, 0 hour. This is the first day of the year at 1 a.m. And in between, you have another measurement. Now, this measurement happens to be an unfortunate case that it's FM16, and we already exclude all the rows that are FM16. But even when you do that, with all the good values, there are still cases like in between hours. Different way of saying this is, in 1 year, we have 365 days times 24 hours. You should have 8,760. We do not have that many values. We have 2 more rows. And in some other files, I saw even hundreds more. So we need to do a bit more cleanup. I think the best way to see that is, well, I don't need to demonstrate it. It's there. It's problematic. But here's the case. If we assume, starting at the top, this is day 1, 0 hour. You go to 23. This is the last, like 11 o'clock at night. So when you go to 24, it's actually the second day, January 2nd, 0 hour. It's January 1st midnight, early January 2nd. There's a big difference. When I said it's midnight for January 2nd, I'm transitioning into January 3rd. So it's sort of semantic, but big difference data-wise. So if we assume that these records are ordered, then we don't need to keep the broken down version of this in fields, because why would you want to keep more information here? More fields here means more data here. Good read. That's essentially increasing the file size, which is now there's going to be an internal timer in the game anyway. So the game code will know which day of which hour, that sort of. So that's essentially what we are trying to, what we are using to find the relevant data. So maybe for simulation's sake here, I don't need to rewrite that. I think this is doing its job, so I'm not going to further this exercise perhaps. Because there's other parts here, whether these have to be scaled down to minus 13.3 Celsius. So there's a lot besides this all string, they actually values. So in other words, there's going to be a whole other layer in the game. It's going to do something with it. And now that I have data to simulate, I don't need to pass this. This is only to turn it into a string because it's here. What I'm interested in is the decoded value. Is going to take the color value and find the real value. This is going to give me float values. The game code will be interested in that. The string figured out. So internally, the game is interested in this. So from the game's perspective, for this to run, data is the image which can be accessed anyway. Need to know x, which is idea and measurement for a certain hour. Okay, we could take some of these functions and already implement the visual aspect. But we've already done this, to be honest. This is a fancier look than this. So that every hour of the game, we are going to update these values. I could even find some of these other fancy values, format them accordingly on the screen. That's okay. Yeah, this is a very big step forward, honestly. Maybe what I was saying earlier, that I was going to start implementing the visual layer, like putting a plant, putting some seed in the ground in May, waiting for a month, and by the end of May, we should start seeing the plant seedling stage. So from seedling, it goes into the next grown phase, then the flowering phase, then the unripe fruit, then ripe fruit, and finally dead state, right? So that's going to be like the whole summer. During that summer, you'll be seeing the numbers change. It's as if we might be close to simulating that. Like kind of starting this afternoon. Which involves decoupling these functions. By the end of tidying this whole thing up and putting it into singletons and such, much more likely they will do this sometime later in the week. This is brilliant news. Simulation is still going. Yeah, this is like 3.1 meters per second. This is also going to be good by 10. This one too for kilopascal because this is hectopascals. I think I'm going to take a proper break. The lunch is coming. We'll continue after the break. I have to strategize a whole bunch of things. If I start the exercise, when food arrives, it'll be very unfortunate to start and stop the thinking process. So see you later after lunch break. Okay. So let's update the stream goals. I would say we are done displaying weather data from a compressed image. Because while the stream has been on pause, simulation has been running. As you can see, it's still running. Every 2 seconds in real life is an hour in the game, and each hour has its own weather data. And we are actually seeing all those values. Needless to say, if we speed up the timer, these hour values will move faster. And the implication of that is that certain plants will die or thrive. So that's kind of where we are to simulate it. First, it's going to take many iterations to get it ready, but we are kind of ready to put a plant and see the weather effects applied on that plant. So as far as stream goals go, we are done. So let's define new goals. And let's also do a quick recap of these goals. So we have refined locations. For now, we are only focusing on Toronto. We took the raw CSV data, we converted to JSON, and we simplified that data. Then we took that simplified data, which is still text, and we converted that to an image. And now we did the other way around. So we take that compressed image and we extract the data. So this is all done. In the shipped version of the game, we will have many more cities other than Toronto. But this process is going to be the same. So setting new goals, simulate the effects of weather on at least one plant for now. Another goal would be simulate the effects weather visually. This is a whole other layer. Speaking of which, we go to product backlog, and I think simplify this, right? Pitch.com. This is a simpler looking diagram. So far, I have been implementing the climate part. Part of this effort is going to include geography. This means the sun's angle, that kind of stuff. But since geography affects climate, we have been interested in the result of geography so far, which is the climate data. Visually speaking, it's sort of missing the let me recap that. We have the effect of geography, but we are still missing certain things like sun's angle, brightness, all that stuff, the cloudiness. Some of that information, I believe, is here. Cloudiness, sun's radiation, angle, depending on the hour and the day of the year. So these two will be worked out together. But as I was saying in the last devlog, number 12, although I would like to implement these systems from top to bottom, whenever it makes sense, I'm going to include the data layer. So we'll take one plant and then we'll see the effect of climate on the plant. So that's what this one is about. We should also see the effects visually. And that's where maybe internally these two systems are interacting. So that geography-wise, if a tropical country is receiving heavy summer rains, well, the climate data is associated with that geography. So we should also see the visual effects. That's what this is. So I'll pull this here. Soil quality is not affected by climate. That's too far-fetched. I mean, you could go about it like in this part of the world we have acidic soil, this and that, but we're not going to include that. Water mechanics is somewhat related to climate. This is how much precipitation and whatever, but that's already handling climate. Here we actually talk about what the player is doing water management wise. Some of this is actually related to gameplay experience, but also if it's rainy because climate, then maybe you should collect water before it hits the soil, or if it's too dry you should collect water to give your plants water, and it cuts down the costs of city water. You don't want to pay for it, that kind of thing. I think besides the visual parts, this has sort of subparts really. Like how much precipitation, right? That's an important topic. So we should see rain or snow depending on the time of the year. That's the visual layer. We should see the effect of wind. I think this is fine for now. Let's look at the data layer here. So we have wind, ceiling height, this is cloud height. Visibility, this is whether it's foggy or not. We'll maybe incorporate the temperature. How can we visually present temperature if things look sort of dry or not? I will put this first. Because when I start this exercise, I'm probably going to branch out and bring many more properties, one of which will be discovering precipitation. So for now, let's simulate the effects of weather on one plant, if possible. It's going to be an interesting and lengthy exercise. Now there is already a weather system singleton. Deprecated because we assume it rains between these 2 hours. That has to be tied to the existing data. By the way, when I'm looking at the temperature here, you simulate the plant's response. This is essentially temperature at first. We will assume they have perfect nutrition, perfect water level, but the temperature is the determining factor whether they grow or not. Let me see how much of this I can salvage. Raining intensity. Doing something. Weather day. Yeah, this all has to be done based on the data again, whether it's thunderous or not. So let's close this. This noise here. Okay, without discovering this, I think I'm gonna have to. Either weather manager or weather. Let's call it weather. Okay, because I'm only interested in the temperature, and there's so much going on here that save this, close other tabs. Most likely need ones. Let's create a new script. This is a whole mess here anyway with scripts and R script singletons such. Let's create a new file here, new script. Let's call this weather. Okay. You did, but there. Oh, that's in the HUD is okay. So you add this to scripts singletons weather. Add this. This should do nothing but print something as stupid as this. Weather or weather. Right. In fact, I think that's a good candidate for changing the stream's topic. Okay. So let's go. So this is going to run when we run the demo or something. Did you have multiple demo files? This is missing that green material, so it's not going to work. I could create a dumb green material in materials. Do a resource material. Special material. Call it green. So we can please the Godot gods. This is that green. I'm not sure what this is running. 5. What's the run? Dave's backyard. Let's just run the utilities is not the. Crime here really. But even here. I don't think this should be really done at this level. Isn't declared any current score. Same old mistake with the soil, with its soil or soil. Tired of it really. Let's open the data layer. Just curious if there's any. This is that data layer. Underscore data. Oil. Let's tidy up all the folders here. Let's go to work, data JSON. If I change this to soil, then this plugin breaks. It's somewhere here. There's a hard-coded dumb case. Yeah, this is it. This should not be. Can't predict that's going to be a problem. On demo. Soil region edit. Item nitrogen. Item being here what? Dictionary data get item. The item simply doesn't have these properties because I change plant to plantoid, and then there was nitrogen and such here in the plantoid. Right. There's actually a plant script too. This has nitrogen. Nitrogen consume absorption capacity, but by itself doesn't really have nitrogen in it. Or it does. Okay, underscore nitrogen. See, but it's sort of hidden here. It's not exposed. This all has to be redone. Nitrogen video. Then we are simply not getting the item. So when you split this, I see S0 blah, blah, blah. Where is this item? EQP sol sandy, which means perhaps EQP sol sandy this. This name doesn't match. Standard sandy. I think if this is calculated based on that, we reverse lookup. That explains the problem. Yeah, invalid get index. This is the index. There's going to be a reverse lookup there. Okay, let's do where is it? Resources here. Reverse. No reverse string was found. What? Imagine it's Sandy. Sandy is this F1B blah blah. Standard Sandy. Is F6. Yeah, so it's standard Sandy. So in other words, this was correct, but this should be standard Sandy. I think that. Okay, I'm fed up with this. I'm going to create this new visual simulation demo thingy for the weather. Let's start by creating a new scene. Let's make a scene. This scene is going to be about weather effects. That's the demo. Okay. Let's save this. Let's make this scene as the run. Let's just run. It's a blank scene. Good. Now I'm going to put a plant, which is going to be a tomato plant. It is going to come from assets. It's going to be this. So here's a tomato plant. Do another F5. We'll see nothing. In fact, we will actually see an error because this plantoid is my script, which should actually be assigned plant. Not. Even that is actually changing now. Let's bind plant again to this. Why has this been moved? It's pro mode under entities. Scripts representation. Yeah, the script dependency is gone. So fix. See. Fixed it. Close. Run. Vegetable. Yeah, because this is a plantoid, is scripts inherits from native type spatial, so it can't be instanced in object of type. Because normally you won't have this plantoid kind here. You'll have a plant script that is actually going to take plantoid as its resource, which is this. Plantoid will be a resource. This is just a resource file. This resource is going to be like a vegetable resource under here. Right? This is missing all these fields, but it's actually going to show. Out of vegetables, I think I created a tomato resource. It's here. I'll have to fix those resource dependencies, that's fine. This is for now going to take plant. Oops. Which is most likely in here too. So that's not how it's supposed to happen later. And plant is I see. It's assuming it should be under a receptacle trellis like that. Um, the architecture here is I think I'm going to need some tea to calm myself down. Uh, I'm about to embark on a very big journey here. Looks like the tomato plant or any other plant can't just be in the world. They have to be part of a container or something. There are some assumptions in the file I can see, so it's getting in the way of us pushing the plant's growth phase to the next stage. So, in order to simulate the weather data based on temperature, we are dealing with a lot of code for this part of the game, which is not done to perfection anyway, so cannot really separate this case. I'll be back. Tea time and writing some more code time. So instead of cleaning stuff, we'll go with the most basic case if possible. So this has been created out of plugin system here. I think this is Mountain Merit. Yeah, the ID is checked. So when we create this asset, this is automatically created for us. Scripts are attached to. However, these scripts are kind of proving to be counterproductive at this point by themselves, but also they assume that this model has to be part of a receptacle, mainly a trellis. That system is also not working for us right now. This is going to have, in these positions, something like this, which is also not working anyway. So, we will most likely come up with a similar architecture later. For now, we are. Let me see, how can I go back to the basics here? Let's see, without having this plant. This plant code is responsible for creating the fruits and other things. What if we remove this? Okay. Good. This file is weather effects. That's our core file, which happens to have just this plant here. This plant only has representation attached. This is as basic as this can get. This is going to be responsible for moving the plant space into the next stage. Instead of looking like this, perhaps it's going to look like this or this. I bet that kind of code actually exists here too. Yeah, all this has to be taken out. Attached to the, not weather system, but has to work in conjunction with. Somewhere here, there must be a piece of code that is responsible for accessing the representation, which should be something like, well, find representation, push the stage forwards. Sounds more like this. Current index. On time passed. The time to grow in this is whatever. Then do +1 and you do Yeah, we push the update condition. So this is pushing it to. So we'll kind of do that manually. We'll be stupid about it. I'm going to create a weather effects script because there's no shame in that. Weather effects. Could be from spatial, I don't care. So let's register the plant here. Let's say already var plant, probably just plant. It is going to be the pln something. No, just your child. Just that is enough. Yeah, that's it. This plant will have presentation. This is going to do something with the code. The representation will most likely have a piece of code, something like, well, right now it has highlight. This highlight, I'm highlighted. Okay, so let's pretend that we are doing that. Too many scripts open here. Junk. Weather effects. So let's do on ready. Oh, ready. Funk. Ready. We do plants representation. Of course, you don't do it like that. You do representation. Get node. Presentation. You do highlight. So when you run the script, even though expecting boolean, this is going to say I'm highlighted. What do you mean node not found? HBox container VBox date time hour value. Why are you running this timer anyway? Okay, I guess that was a boo-boo. An old error. Okay, moving forward, weather effects. So weather effects is not showing anything on the screen, but it's accessing this plant's representation. So we can do something like, let's say this plant is starting at no phase, an empty plant. By the way, we cannot see anything because there is no camera in weather effects. Let's include our camera, which is also going to look for a ground object with a collider. So this has always been a problem. So sort of repeat those problems. Speaking of which, Dave's backyard. Let's open this. There's this stuff that I want to take. Put it here, ground. Let's also take the camera too. This is actually level. The demo itself is including the level Dave's backyard file too. Should be something about demo is also I think I finally made it into the game here. Yes. Level container. We could have worked things out from here too, mind you. Let me run this post. Timer post. Timer. This timer. Timer. Game. Time. Pod. So is this time part of the built-in time? It's fucked up. Okay, the lesson we have to learn here is that we take this camera. Gotta put it here. This camera is going to find this ground, and we also need environment, which is bringing the sun and such. So if we stick that in here, we should actually have something to look at, some sun and whatever. So let's run this weather effects. We should be able to see something. Kind of did briefly. We gotta see where this camera is position wise, offset. Yeah, those values are also right now. This camera is showing this direction and the plant is not there. For this to make sense, gotta move it maybe this way. I also think these values are not correct. Let's see. Here we go. Maybe let's do this 7-7 because I have a feeling that's really going to sit. Close enough. You can zoom in, move left and right. The sensitivity is a bit off, but it's okay. We're only interested in looking at this plant and weather's effects. Is there anything else we can bring from here? Pod maybe, which okay. Environment, we brought it. Dave's backyard is the level. So this is where the real game will happen in the future. We'll maybe load new levels and the rest of the information. Let me look at this environment. Yeah, I Pro, bake it. Not sure if it's gonna make any difference. Okay. Well, here's the tomato plant in its glory. So this is what's missing right now. My mind. This here. Now, I'm kind of afraid if I bring in there's like a HUD system, right? This says weather. If I bring this in, this is waiting for certain events to happen, so it could update its information. For example, this part in the temperature, let's say. Let's look at this part, which is this is a complex bit here. This has its own script. Integer temperature. As opposed to date fonts. Temperature is changed, update temperature. If degree, get node or null degree. I do remember putting these, but I mean, how do you even start? New color. Why would we change the color is black? Font resource. But this is always coming from the theme anyway. Why is this even here? If get child count is more than 0, if it has anything, but it always has something. Update color. It always has something. I don't understand. It's green. Here, but we could always make it green now. Here is green. Just do one color here. This is custom to this. Sure what the intention is. Anyway, this seems like one of those cleanup cases. Maybe in the future we'll need something here to change the unit from C to F if necessary, although I always want to stay with the Celsius or metric system. Okay, in other words, this is discarded for temperature. Okay, either way, here's what I think the main problem is. If I go to weather effects, if I want to include weather as this, no parent to instance a child at. Right, here's the weather scene as this. This cannot be imported into here. You gotta stick this in either a viewport container or you gotta put this in a canvas layer. Hence the whole HUD. To just stick this in here. Now when you run weather effects, see, this is where the black thing is coming in, because the font is, this is all butchered anyway. The lines are gone. This is not rendered properly. Anyway, it's trying to do something. Right now, it's putting itself there. So let's remove this code. It can be top left. Here's the plant. So when we run the simulation, these numbers will be populated properly, and then we'll get to see this, hopefully. I think I'm going to have another half an hour or 40 minutes tops, and then call it a day. We'll see. So we normally have this is it in the HUD? You can go to 2D view. Day, hour counter and such. Don't think this will run by itself because it's expecting some stuff. Yeah, this is not the most efficient system, to be honest. This HUD, having an opinion about the house and the 3D items from the world This is tightly coupled. All this has to be rewritten. The reason why I'm saying that, because for this, I need some kind of day-hour simulator here. So under here, maybe we can put basics from here, which is the top panel. If I just import this, suppose we just do top panel. No parent to instance a child. It's awesome. Copy this, paste here. We did that. So let's run this. So supposedly it's running, but it's not updating the values. Event bus connect time passed, because the game is actually not running quite the way we expected it to be, because normally there's probably another system that is triggering. We'll go back to tomato tutorial, just tutorial. Levels. Oh boy. Oh, this is, yeah, those panels. Time pose, true. So this is kind of starting the game. Okay, we need this time thing from here too, which is weird because this has a visual layer, but it's also doing some. There's no script element here, however, that's the bizarre part. Old top panel, that's here. But now there's apparently a new time. Let's see. Just this. So all we gotta do is time pause then here. Post in time GD timer. The timer is none other than that other timer. And calendar is here. Fine. Okay. So further investigation has revealed that I may have to rewrite a whole bunch of things because it's really, really, really not not intuitive to find where things are triggered in. So calendar seems to be part of the top panel. Seems to be this. And the old timer system has been relabeled as old top panel. This is not updating because the timer is not starting, but when we start it, it says this timer object is not found, which means this is not in the tree. When I look for that in the tree, hard to follow. Hard to follow. I mean, this hot tutorial may have its own thing here. Because it's here, which I do remember writing this code, but this was always attached to a time scene. It was time this, which is a singleton. But this doesn't exist in the tree. This is also not existing in here either, which is the problem. This time should not be here. This should be time scene itself, not the script. Should be this. Add this. And okay, enable it. Close. Now when we run this madness, something happened. Actually, the timer kicked in. I can't see that because the HUD weather is the old HUD, which is, yeah, this is what I was actually worried about. This is trying to run with the old code, which has just been triggered when we enable the timer. Which also means that we don't maybe have to do this part yet or anymore. After 1 second, it says what is update temperature, what is current temperature. Current temperature is V-Box, content V-Box, 3 container 2, temperature, date temperature. Because I removed that script, that's why this is happening. Temperature really, right? This is it, because I removed that script. So let's just stick the script in there, but where would that be? Script integer temperature. This is, let's run it. Yeah, that's it. So it's moving, it's doing something. Now we'll dissect this. Let's fast forward the time. This is going to fluctuate between some. I believe there's a way to fast forward the. This is not working. If it did, this is when we do the time post and something. Fucked it up because it's now in pause mode. Yeah. environment, get temperatures, taking. There are a lot of systems here interacting with each other. This urban environment, perhaps this is a mislabeled thing. This sounds more like a weather system, but it's comprising weather plus the night colors and everything about the world. So this is more like world or environments, kind of. But it's also doing the weather stuff, which means when you come here, here, it's also looking up the predictions and such. Yeah, we need a decent architecture here. I can't spend days. It's like a maze to unravel it and then put it in its right place. We need a better architecture. Just need to draw things and do a proper thing. I believe this is representing the object entity system. Yeah, object classification. Really what this is. This flowchart is this is talking about the composting system. It's called composting. Go back. Okay. We need a new chart, new board. Is there any board about software architecture thing? Of layers. Google Cloud architecture diagram. These two look helpful. Yeah, let's use it to see. Object classification will become view only. Upgrade to create. Sure. Pretty graphics. 3 objects. 1, 2. Is a group. Shape image text. I see. It's a transparent shape, so the arrows don't butt against the. Okay, something like this arrow structure might help. One thing I'm kind of curious, can you create sub diagrams? Meaning, if this was a system that we clicked, would it take us to another diagram? We could actually look at it. Upload. Mind map. Kind of need process and flow really. Seems to be this. Can we import another diagram in here? Templates. Okay, let's go with this first. I don't think we need this. Okay. Let's just call this game in a dumb way. This is the game, right? Game starts. Game has some systems, camera, whatever. I'm not writing that now. It's okay. This image here is suppose you could let's just be a little bit, let's do it in a fun way. Okay. Let's do weather free. This is all free, right? I think so, last I checked. Yeah, weather free icon. Copy. So you just paste it here. Okay. I see. So let me write down some system names here. So we have weather. We have current weather. We also have, we can tab here, right? Weather, current. Let's just do this. Current. We also have forecast. Okay. We have environment. This is responsible for I'm calling it accumulation. This is going to be responsible for precipitation, whether it's rain or snow, that kind of thing. We have a time, game time. Okay, we have a system like this, which is essentially all games are running on a timer system anyway. There's an internal clock there. This is kind of like game / time. Same thing. Ish. The reason why I'm actually bringing this up, because this time is a separate entity, because we will also have something like a vendor system. By vendor system, I mean this, that the player will be able to shop. So when the time goes on, or as time goes on, move forward, the prices will change, the availability of certain items will change. So in essence, if this was a vendor system here and there's a time system here, this should make a call here to say, well, the direction of the arrow doesn't matter, but there has to be a call made to the vendor system to update certain values. Sometimes the effect will not be direct. Sometimes time will affect a certain system which will affect another system without this system directly interacting with the time system. So this is not necessarily a single layer thing. There will be, we will take all this and then lay it out here. And then we'll write our code to reflect all that interaction. Okay. So then we have what I call plant system. Now this plant system is essentially the data layer here, and all this is actually systems too. So when I say weather, I actually mean climate. And by this we also mean geography. And I talked about how geography and climate can be considered the same thing. Then we have a soil system. Okay. This soil system also involves share similar mechanics with compost. So let's also write that here, composting. And this is water management. That's really what it is. Okay. And this water management is, in essence, part of this too. But this is sort of the result of which affects this, so which makes this redundant. What other environmental things we can think of? Day-night cycle, which is part of the timer anyway. Temperature, which is all part of weather. Okay. There's the plants, and by plants I mean every plant, whether it's herbs or mushrooms, anything of that sort. Gameplay experience is then we have really player interaction. So let's this is sort of a subsection, right? Accumulation, precipitation. It also has temperature system. Many more systems here. This environment now is in limbo. This is player interaction. For example, what happens when you put a new plant in the world? What happens when you remove a structure? How is it affected by all these, and how is it affecting all the rest? In 5 more minutes, I'm concluding. I also have another list. This has been already summarized in this fashion. This is world interaction, landscaping, all that stuff. Talks about object placement. Like I was saying, what happens when you put a rain barrel, right? That's player interaction. And this is growing mechanics. Again, if the player puts one of these things, how does it interact with the plant system? And this part is scenario based, some goals, flavor, cultural elements, that kind of scoring system. That's fine. So there's equipment structure, damage system. That's like environment, but also objects too. There's post-harvest player activity, which is under player interaction. And under this, I'm including inventory too. This is the vendor system. Suppliers, manufacturers, I wrote that down, right? I did. There's non-functional stuff. This is the data layer that I'm talking. Yeah, we're already doing this. This is no different than plants. So call this fauna, and sorry, flora. This will be fauna. Okay, let's try to dump this here. Do a few basic things and call it a day. So, just the weather system. Can we create something very quick like this? We just did, and then I just drag this in here. Work like that. You cut this. That's interesting. Can you even change the source? Oh. This base image, base from board. You can image on the board. This one. Good. Okay. Weather system. Maybe I'll do it like this. Okay. Let's look for one more icon, and I think I'm calling it a kind of like market vendor. This looks colorful. Take this. Dump it here. Duplicate this. Place. Confirm. Done. And copy this render. Okay. On that note, I think that's it for today. I have to do this architecture flowchart. Either during the next stream or before the next stream, but either way, in the next stream, we will be looking at cleaning up, or most likely writing from scratch, the systems that we need. Essentially, we need to look at values increasing here in the time, and these values reflecting current hour's temperature and the plant reacting to that temperature. Right now we seem to have something working, but this is haphazardly done. Maybe along the way we'll also fix the layout here. That's it for today, so have a good week.